Okay, so let's get started. First of all, thanks for coming to this session. I know it's the last day and it's almost the end of the KubeCon, so it's a little tough to come here. But my name is Yong Tang. I'm a maintainer of CoreDNS project. My co-speaker, Belamaric, he unfortunately cannot attend this session, so I'm going to host this session on my own. Let's get started. In today's session, I'm going to discuss about several topics. First, I'm going to introduce a little background about the CoreDNS project itself. I'm going to discuss about what has been happened for the past year and the different update as well as releases. Then I'm going to go deep dive into CoreDNS project, discuss about how to scaling up, especially for virtual scaling of the performance with the newly added multi-socket plugin. And also, I'm going to discuss about the service discovery with CoreDNS, especially how CoreDNS can be a single source of truth to sync up with different cloud vendors for DNS record. Finally, I'm going to discuss about community involvement and how you might be able to help CoreDNS as a project. As many of you know, CoreDNS is a flexible DNS server written in Go. It has been there for quite a few years. It started around 2016. At the beginning, it was actually it was a fork of Caddy web server. Over the years, we make a significant change to convert Caddy's HTTP traffic into UDP traffic processing. We also add a lot of features. Over the years, one of the significant features is about Kubernetes integration. So since then, it has been adopted and has been added as a default DNS server for Kubernetes. That triggered the explosive growth of adoption because of the growth of Kubernetes itself. One of the biggest advantage of CoreDNS is CoreDNS is plugin based, so which means it can be easily extended. In other words, if you have a need for a new feature and the feature is not available in current CoreDNS project, you actually can just write a plugin yourself with a minimum line of Golang code. In fact, with today's AI, you probably can even do it on your own, even if you don't know anything about Golang. You can give it a try for sure. The CoreDNS, as many of you know, it's a DNS server, first and foremost a DNS server, so it supports DNS protocol, but it also supports DNS over other protocols like DNS over TOS, DNS over gRPC, and DNS over QUIC. Another nice feature about CoreDNS is integration with different cloud vendors. Let's say you have DNS infrastructure hosted on AWS, Azure, or Google Cloud. You actually can place CoreDNS as part of a single source of truth to sync up with a different backend and give you a single pane of glass when you are trying to present your DNS service as a whole. I'm going to elaborate this cloud sync up a little bit later in this session. By the way, I do want to mention one thing about CoreDNS as a project. Unlike many open source projects, CoreDNS is pretty unique in one way. CoreDNS by itself is not backed by any big companies, for sure. It's totally community-driven, totally contributed by individual contributors, not associated with any company. Over the years, we have a lot of maintainers join this community, make it significant change to this project. CoreDNS itself is also not backed by any startup. We all know there are some startups, they give you an open source project, but if you want to find any so-called extended feature or enterprise support, they're going to charge you money. But that's not the case for CoreDNS. Totally grassroots, open source project driven by the community. So hopefully anyone can get a better understanding. Hopefully you can contribute to this project if you feel like that's worth your effort. CoreDNS itself has been a growing community. As of right now, we have more than 400 contributors. On GitHub, we have 13,000 stars, and it's growing. We have 38 public adopters. That means many institutions, they are willing to share their name with CoreDNS and put their name on the project page. By the way, as I mentioned, CoreDNS itself is a totally community-driven project. So they just add their name to this project. There's no, commercial interest conflict or anything. Just make sure everyone understands that. We also have 29 maintainers. This year we added one more maintainer. That's from Ville. He is from Finland. That demonstrates CoreDNS has an outreach to around the world. Ville joined several months ago as a maintainer. He made significant change to security. He contributed to 2 CVE discoveries. He also made quite a few fixes for the project. I'm going to discuss about how you may be able to become a maintainer as well if you have interest later to this session. Okay. Since last year, there have been quite a few releases. There are two releases that's fairly significant. One is 1.12, another is 1.13. The latest release was 1 month ago. That's 1.13.1. For the past year, there are 2 significant plugins that have been added. One is a multi-socket plugin, which improve the vertical scaling a lot. I'm going to deep dive into multi-socket plugin today as well. We also added a Nomad plugin so that you can potentially use CoreDNS to serve the DNS record if you have a backend for HashiCorp Nomad. There are also some other features like multi-class support for Kubernetes plugin, several special features like a prefer option in load balance plugin, as well as the fall-through support in gRPC and the 5 plugin. As I mentioned just moments ago, we found a couple of security vulnerabilities by our new maintainer. There are 2 CVEs has been filed. Our security vulnerabilities mentioned here has been fixed with the latest release. So if you haven't done so, I encourage you to update to the latest one as soon as possible because they are fairly significant. Okay, I'm going to deep dive into a multi-socket plugin a little. So for multi-socket plugin, before I discuss this one, I'll just explain how exactly the CoreDNS works when they receive a packet. As you can see, DNS server always bind to UDP 53. For CoreDNS, before multi-socket plugin, it will bind to this address of 53 port number. It will spin up a server. This server will receive the packet, do the processing, and dispatch the packet to different Go routines so that it can be distributed. This is fairly good because you have multiple Go routines that can run. The downside, obviously, is that you still have the bottleneck of the socket binding to 53, so you only have one. This turns out to be a drag on the performance, especially when you have a beefy box of, let's say, 16 CPUs or 32 CPUs, beefy box. You realize that CoreDNS has a hard time to do a vertical scaling. This has been recently resolved with the additional multi-socket plugin. But how do we handle that? Of course, we can say if you only listen to one port, how about you spin up multiple instances to bind to different port numbers. For example, you can have like 53 or 54. Great. Then certainly you can just do a horizontal scaling to have a multiple copies to saturate your total number of CPUs. But the problem is, as an average user, you may not be able to force your average user to change their behavior or change their the way of connecting to DNS server. So that's most of the time that's a no-go. But recently, one feature has been added. That's a multi-socket plugin. So we can actually create use a special flag in kernel. That's SO reuse port, which actually allows you to have multiple functions bind to the multiple socket bind to the same port. So you potentially can have, let's say, two sockets listen to the same port of 53. Each socket can be dispatched to different Go routings. This significantly improves the performance and especially allows you to saturate your B3 box of 16 to 32 cores or even bigger. This turns out to be a significant change and has been one of the biggest advancements for the past year. So I'm going to show some of the numbers here. This is initial performance numbers without a multi-socket plugin. As you can see, it's saturated around 40,000 QPS. No matter how you spin up more CPUs, it just saturated around there. In fact, if you add more CPUs, it's actually going to get worse because different like different Go routing may compete in each other. You have context switch back and forth. That may make things even worse. But with the multi-socket plugin, you are able to scale up significantly with just a two socket. With two sockets, as you can see, the bottleneck has been gone instantly. The total performance number, the QPS, has been increased to around 100,000 QPS, even with just two sockets, and it's able to saturate at least 4 cores. That's a big step forward for sure. You can certainly add a little more. Let's say you have 3 sockets. It goes further, goes to about 150K QPS, which is great because you can saturate more CPUs. And the thing is, the more CPUs you saturate, the better, because your CPU sitting idle, it's just serving no purpose, right? For sure. So you can increase a little more, like you let's say 4 sockets. That's great. That's reaching 200K. A little more, that's 250K. And eventually, you will be able to get into around close to 300,000 QPS. This is significant. It actually saturated almost 14 CPUs. As you can see, it's linearly increasing, which is great. You can even add a little more. So this is pretty good because that's removed the bottleneck of DNS server, the CoreDNS, in the past for many years. This contribution was done by the community, which is a great deal because it shows the community are truly not from maintenance, but from an external community. They decided to contribute to this plugin, and it's part of the CoreDNS ecosystem. Now it's part of repo, so you actually can utilize a multi-socket plugin now. So how do you utilize this one? This multi-socket plugin has been there since 1.12. It requires SO reuse port, but in the config, so what do you need to do? You only need to have one line of just specify multi-socket in your core files, and that's it. You can optionally specify the number of Go routings you want to leverage, but that's it. By default, it will select the Golan's default Go max procs to decide the number of Go routines, but our experiment has showed that if you don't know what's the best way to optimize, you can just leave it alone, just specify multi-socket, and this config file is good enough to scale up your CoreDNS server and saturate your number of CPUs as much as possible. Okay, so that's a multi-socket plugin. Okay, so I also want to cover a little bit about CoreDNS for service discovery and multi-cloud deployment. Many people ask the question and say, okay, so nowadays you have SDN, everything can be virtual. What's the deal with DNS? Sounds like DNS is just a string and pointing to an IP address. But there are some reasons for DNS to be there. So first of all, DNS is a nice indirection, and this indirection actually helps you when you need it. It gives you the maximum flexibility and allows your user to not change their behavior while you can make an infrastructure change from the backend. The DNS itself can be public facing, can be internal, but it's actually very much the core of the networking infrastructure. DNS by itself is easy and simple to change. In CoreDNS, many of our users actually use CoreDNS in a way such as they just place a host file with, let's say, 200 DNS record, and they serve really well and scale up really well. That by itself means that simplicity is a key to CoreDNS success. The DNS itself is also distributed in nature. Why? Because it can scale to the internet. The internet itself is backed by the DNS infrastructure. In fact, I think a DNS protocol is probably one of the most underappreciated protocol in networking space, because many people didn't realize how sensitive DNS can be and how critical DNS can be. In fact, if we talk about the cloud, nowadays with all the cloud vendors, people treat DNS as a niche service, costs you maybe like pennies, but when it goes wrong big. For the past several years, if I remember correctly, one of the major vendors has a significant DNS outage for at least 2 to 3 times. That caused, one outage actually happened just a month ago. That speaks volume to say how sensitive DNS service is. By the way, as far as I know, for now, all the cloud vendors already guaranteed a so-called 100% uptime of DNS service they provide. But I wanted to be cautious on the meaning of 100% uptime. 100% uptime means they will guarantee the service will always be online and will always be available. But what if there is something wrong? If there is something wrong, let's say your service has been impacted, it doesn't mean they are going to compensate the money for your loss. It only means if you consume their service, the DNS service, and the service has been down, they are going to compensate back for the loss of the service incurred due to the outage. Not your service, but their service. And think about how much money you're going to spend on DNS. Tiny. And that's what they're going to give back to you if there is a service outage. So like I said, it's a highly sensitive service. It's so simple, but many people underappreciate the DNS and the importance of DNS. And just think about that. Let's say you have one cloud vendor has a service outage. You spend, let's say, $50 on DNS service for a whole day. Okay, so they're going to give you $50 back. Okay. But at the end of the day, I think a DNS service is important. It's also a very, very good service in that the DNS service is actually a simple solution for a complex problem. Of course, that's much better than a complex solution for a simple problem, right? For service discovery and cloud vendor integration, why do you want to use CoreDNS to sync up with different cloud vendors? You can certainly use a DNS protocol to sync up. For example, let's say you have a Route 53. You can just set up your DNS server and point to the UDP to Route 53's server and use the UDP to do all the communication. But this is not exactly the best way because the UDP by itself is not secure, right? It's also stateless. So if anything goes wrong, you may not know what could be wrong. Debugging has been pretty painful. The error message can be a little cryptic, so you don't know what could be wrong. So with CoreDNS, when we connect to cloud vendors, we actually use HTTP and with the API. So that gives you the authentication, authorization. It's much more reliable, and it gives you better error handling. And also, with the CoreDNS front end, you can separate data sync up and DNS query. So your DNS query from your, your users are still the same. But from backend, the data transportation in between your cloud vendor's DNS record and your front end is actually done through the TCP and HTTPS, which is much more secure and reliable. At the end of the day, with the CoreDNS as a front end, you actually have an option of consolidate of different data sources as a single source of truth. I'm going to show a diagram that can give you the idea of how exactly CoreDNS is going to work. In this case, as you can see, let's say you have deployment on different cloud. Let's say you have AWS, you have deployment, Kubernetes deployment on Google Cloud. You also leverage some of the services by different cloud vendors, but you have DNS entries from different places. Now, with DNS at the front end, you actually can consolidate both, and even with additional entries to serving even your internal IT infrastructure. They can be separated with different configurations so that different queries can be routed to different backend. But your front end remains the same, and the user don't need to change anything. They can use a good old DNS protocol to serve their need. So this is just one setup that can work for different cloud vendor sync up. Now, how do you get there with CoreDNS? The configuration is fairly straightforward. You specify, this is a profile, by the way. You can just grab this one, make a little change to different parameters to fit your need, and that's it. So the first entry is route 53. It will route any traffic with CoreDNS example.org to route AWS route 53. So if user query your CoreDNS server, it will first go to AWS route 53. So okay, if there's any record. If there's no record, you specify false rule so that the CoreDNS will just get to the next plugin and will go to Google Cloud, try to figure out if there's any DNS record that is able to match your request. If not, you can follow through again with your local setup or even your IT infrastructure's DNS record, or even somewhere else like Nomad, wherever you want to go. Like in this case, that's a Who Am I, which is just a pseudo hello world DNS server. And with this one, it consolidated different DNS sources from cloud vendors of AWS, Google Cloud, as well as your local DNS record, and present your user with single pane of glass. Okay, so I think that's a good example, and it's a fairly simple example. As you can see, just several lines of configuration. That's good enough. Okay, so I think we cover a lot. I'm going to finally, I'm going to discuss about how you can make a contribution or make an impact to CoreDNS project. As I mentioned, CoreDNS project by itself is not backed by any big companies. It's also not backed by any startup trying to sell your enterprise service or try to sell your additional licenses. It's totally open source, totally free, and we welcome any contribution from anyone. You can do several things. You can certainly start CoreDNS in GitHub, that's for sure. If you haven't done so, I encourage you to add one more star to CoreDNS. You can add the name of your institution to adopt this list if the institution you work for is willing to share their names. You can also become a contributor. For example, you can create a pull request for features or bugs, or even just create a pull request to add your institution's name to adopt this list. You can also find security vulnerabilities, and you can file a CVE privately first. So once we get the vulnerability fixed, we can make it public. And finally, if you want to be a maintainer, it's fairly easy, and you cannot imagine how easy it is. The criteria has been fairly low, and that's the reason why we have a truly transparent and a truly welcoming community. If you can make one significant pull request to be merged, and if you are able to find one existing maintainer to add you, and you will be a maintainer. And that's a very low bar. And the reason is, like I said, there's no big companies behind CoreDNS, and we are not backed by anyone. So we welcome contribution, and we want more maintainers for sure. Yeah. I think that's it for today. I'm just wondering, anyone had any questions want to raise? Any questions? Okay, I think we have no question, but thanks a lot for coming to this session. Have a wonderful rest of the day. Okay. Oh, you have one question. All right. Okay.
Is node local DNS something that is supported by CoreDNS in any way?
Sorry, can you repeat the question again?
Node local DNS, the Kubernetes project to run CoreDNS in each node as a daemon set? Or
Yes, no local, certainly that can help a lot to scale the performance. I think that's one of the ways that have been used by community when they try to cache, because the DNS, while the DNS itself, I'm going to say, look like a simple service. The caching has always been a thing, and in Kubernetes, if you have a service up and down frequently, there will be a big burden to Kubernetes API servers. And with the node local cache, that definitely helps a lot. Okay.
Thank you.
Okay. Thanks, everyone. Have a wonderful day.